Okay, so your study guide for tomorrow's test. The first two problems you are asked to solve a linear system by graphing. So if you notice, number one is already in slope-intercept form, which slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. I'm going to do the first equation in red. So my y-intercept is -6. Be careful on your coordinate plane because you have a scale of 2. So it's going by 2's here. Be careful, especially when you're doing your slope, because your slope, you're going to go down 1, which would be in the halfway point, and then you're going to go to the right 1, which would be right here. And remember, when you're doing these problems, you want to put as many points as possible. You want to make sure your line is as straight as possible so that you can get an accurate solution. It's going to be hard for me to do that on the iPad, but I'll try. Tomorrow's test, you could use a ruler if you need to. Then your second equation, which I'm going to do in blue, the y-intercept would be 0, and your slope would be 1. So you rise 1, run 1, rise 1, run 1, rise 1, run 1, etc., etc., etc. And in this case, because both of the slopes were 1, you could have actually risen up 2 spaces and run 2 spaces, because that would have been equivalent as well. And if you notice, it looks like they intersect at this point that I'll do in green, which is right here. And that looks to be -3, -3. That would be your answer. So now we have one that's not in slope-intercept form. So the easiest thing would be for us to change this to slope-intercept form. We would subtract both sides by 2/3 x. And I'll go ahead and write all this out, just in case you're still struggling with changing equations to slope-intercept form. So if it's this right here, we would subtract by 2/3 x on both sides, right? Because we want to get it in the form of y equals mx plus b. And that'll change this to y equals -2/3 x minus 2. And there we have slope-intercept form. So if I go ahead and do this top one first, it's y equals 1/2 x plus 5. My y-intercept would be 5, which would be right here. And it looks like it's a slope of 1/2. So I rise 1, go to the right 2, rise 1, go to the right 2. And that would be that. And you can go the other way as well. And remember, you want as many points as you can get for this in order to make it as accurate as possible. And then my second one is 2/3 x, slope-intercept form would be y equals -2/3 x minus 2. So my y-intercept would be -2. And it looks like I'm going to go down 2 and run 3. So down 2, run 3. Down 2, run 3. And you want to get as many points as you can. And if you do that, it looks like they intersect right here, which would be -6, 2. Now we're solving each system by substitution, which means we need to solve for one of these variables. If I look at this top one, it looks like the easiest variable to solve for would be x, because the coefficient on x is 2, and I know both 6 and 16 are divisible by 2. So that might be the easiest variable to solve for. So let's do that. So if we're solving for x, I'm first going to want to move the y. So I'd subtract 6y on both sides, which would give me 2x equals -6y plus 16. And again, if I'm solving for x, I'm going to want to divide everything by 2 to get the x by itself. That would give me x is equal to -3y plus 8. And then I would have solved for x. Now I would just plug this into the y part of my second equation, and that would be the substitution method. So it would be 3x. I'm sorry, I said the y part, I meant the x part. I'm going to be plugging this in for x. So let me fix this. 3 times -3y plus 8 minus 5y equals -18. And you'd solve that, so that would be -9y plus 24 minus 5y equals -18. You combine like terms, and it would be -14y plus 24 equals -18. You subtract 24 on both sides, and you would get -14y is equal to -42. and you divide both sides by negative 14, and you get your y, which would mean y would equal, that is positive 3. And to find your x, you would just take this value here and plug it into one of your original equations. You could even use this equation. And if you do that, I'm trying to make this video as short as possible, but you could just go ahead and plug it in. If you plug it in, you figure out that x is going to equal negative 1. So these two lines would intersect at negative 1 comma 3. So substitution means I want to solve for one of these variables. Now this one, if I look at all the coefficients, it looks like I'm going to wind up with a fraction, whichever way I decide to do this. Because if I solve for x, right, 4 isn't divisible by 3. If I solve for y, 3 isn't divisible by 4. And the same on the bottom. If I solve for x, 8 isn't divisible by 6. And if I solve for y, 6 isn't divisible by 8. So either way, we're going to end up with a fraction. So I'm just going to choose the top one, and I'll be prepared for the fraction when it comes. So I'm going to go ahead and solve for x. Do you have to solve for x? No. You just need to solve for one of the variables. I'm going to solve for x, and the way you do that is you'd first subtract 4y on both sides. And if you do that, you get 3x equals negative 4y plus 36. And you divide everything by 3. And you would get x is equal to negative 4/3 y plus 12. And you would plug that into your your equation over here. So anywhere I see an x, I'm going to plug in negative 4/3 y plus 12. All right, and we would go ahead and distribute. So this is actually going to give me negative 8y plus 72 plus 8y equals 48. So this one's going to be interesting because these are going to cancel out. We're just going to be left with 72 and 48. So when that happens, you just need to look at the numbers. If they equal each other, that means that there would be an infinite amount of solutions. It would mean that these two lines would actually be right on top of each other. If they don't equal each other, that would mean that these two lines are parallel, which means there are no solutions. All right, these are going to be a bit easier. This one, we're going to solve using addition and subtraction. We're going to solve using elimination. And we don't have to change anything with this one because look at that. That's awesome. We could already cancel that out. So these would cancel out, and I'd be left with 6x equals 36. Okay, and then I'd solve by dividing by 6, and I would get x equals 6. All right, then all you would need to do is plug in 6 into one of your original equations, and if you do that, you would get your answer, which is y equals 2. So these two lines would intersect at 6, 2. This one you also wouldn't have to change anything at all because we already have opposites. So actually the x's would cancel out and the y's would cancel out, and we'd be left with 0 equals 0. Does 0 equal 0? Yes. So that would mean that these two lines are actually right on top of each other, which would mean that there would be an infinite amount of solutions. So now we're going to solve these by multiplying first. We're going to have to multiply first. If we look at this, it looks like the easiest thing I'd be able to do is change this to a positive 4x. Because what would happen if I change that to a positive 4x? Positive 4x minus 4x, that would cancel out. Let's do that. So how would I change this to a positive 4x? I would need to multiply the entire top equation by negative 2. If I do that, I get positive 4x minus 4y equals negative 4. And then on the bottom we have negative 4x plus 7y equals 16. Add these up together. These would cancel out. We'd be left with 3y is equal to 12, which would mean that y is going to equal 4. How do you find x? You're just going to plug it into one of these original equations. And if you do that, you would get x is equal to 3. So your point of intersection would be 3, 4. Looks like the easiest one to multiply here would also be the top one, and I would just want to change the x to negative 5x, which I would do by just multiplying by negative 5. Could have also changed this, and that would have just been just as easy. And if you want to try to do that on your own and see if you get the same answer as me, that's fine. So if I multiply this entire top equation by negative 5, I get negative 5x plus 20y equals positive 5. Now on the bottom I have 5x plus 2y equals 17. These are going to cancel out. I'm going to be left with 22y equals 22. So y is going to be equal to 1. And if I plug that into my original equation, I would get and that's how I would find x. If I do that, I would get x equals 3. So these two lines intersect at 3, 1. So let's graph this inequality. We're first going to want to change it to slope-intercept form. And you know how to do that. If you forgot how to do that, take a look at the first part of this video where I actually took a problem and changed it to slope-intercept form. But right now, I'm just going to pause and do that so that this video doesn't take too long. So you should have gotten y is less than or equal to negative 3 halves x plus 6, which would mean that your y-intercept is 6, right? And your slope is negative 3 halves, so you're going to go down 3 and to the right 2, down 3 and to the right 2. And you're going to want to put as many points as you can so that you can get as accurate of a line as possible. So because this was less than or equal to, I'm going to use a solid line, right? And if we look at our formula, it's y is less than or equal to negative 3 halves x plus 6, which means I'm going to shade the bottom portion of this line. Shade the bottom portion of this line. And that would be my solution to this inequality. Again, I'm going to go ahead and change this to slope-intercept form. So that would be negative y is greater than or equal to negative 5x plus 4. I'm dividing by negative 1 here, or by negative, so I need to flip the inequality symbol. And it would be y is less than or equal to positive 5x minus 4. So my y-intercept is going to be negative 4, right? And then my slope, I'm going to rise 5, go to the right 1. Okay? And there's my line, and it's y is less than or equal to 5x minus 4, which means I'm going to shade below the number line. And I used the solid line again because it's less than or equal to, which would mean it would be solid. Number 11, graph the system of linear inequalities. So both linear inequalities are already in slope-intercept form. Let's graph it. I'm going to graph the top one with red. So the top one, my y-intercept is going to be 10. So it's going to be the top point here. And then my slope is negative 1. So you'll go down 1 to the right 1, down 1 to the right 1. Or you could go down 2 to the right 2, since that's also going to be equal to negative 1 as a slope. And then you go ahead and draw your line. Now this time it's going to be a dashed line because it is, oops, what did I do? Because it is less than and not less than or equal to, so we're going to have a dashed line. And which side am I shading? I'm going to shade below because it's a less than sign. So that means below the line. And that would be the solution to that inequality. Now I'm going to do the bottom one in yellow. So the bottom one, my y-intercept is going to be positive 7, which is right here. And my slope is going to be 1 over 10. So I'm going to rise 1, and then I'm going to go to the right 10 spaces. So I'm really going to be able to only put 2 points here. And I use the dashed line again because it's less than. And then I'm going to shade everything below the line because it's a less than symbol, so that means below. And what's my solution? The solution is where they overlap, or where I have both red and yellow, which I'll go ahead and do in green. And that's this area right here. This is where they overlap. That would be your solution to this set of linear inequalities. The last problem is also in slope-intercept form. So the first inequality will have a y-intercept of 6, and I'll do this one in blue. We'll have a y-intercept of 6, which is right here, and my slope is 2, so I'm going to rise 2, run 1, rise 2, run 1. Okay? And for this one, I'm using a solid line because my inequality symbol is greater than or equal to symbol. So therefore, we're including that line in our set of solutions. All right, and which side of the line am I shading? I'm going to shade above the line because it's a greater than or equal to symbol. So I'll shade this side right here above the line. Next, we have y is less than negative 1/2 x minus 1. So my y-intercept is going to be negative 1, and I'll do this one in red, which is right here. And then my slope, I'm going to go down 1 to the right 2. Down 1 to the right 2. That would be my slope. This one will be a dashed line because it's a less than symbol. So we're not including it in our solution set. So it'll be a dashed line just like that. And its y is less than, which would mean we're going to shade the bottom portion of this line. And you can already see where they overlap, which would be, I'll do this in green again, this green section right here would be the solution to this system of inequalities. I think this is another video that's around 15 minutes, so awesome. I'll see you tomorrow. Study for that test.